This is the second problem on the MinMax worksheet. I think people have less trouble with it because we've seen it a few times in class. It says a man has a stone wall alongside a field and he's going to use 1,200 feet of fencing to build a rectangular pen. The first thing people are concerned about is whether or not this wall is sufficiently long to build the fence. That's not what we're worried about in the problem. If he's going to build the fence, the wall's big enough, so we won't worry about that. So there's the fence, making the rectangle with the wall. We'll use x for two of the sides and y for the other side, assigning our variables like we did in the first problem. So he's got 1,200 feet of fence. That's our constraint. That's what tells us how big that fence can actually be. We have a variety of choices. One of them will be the biggest area, but the 1,200 does limit the total number of choices we have because that's all the fence we've got. Reading the problem, you can say that we want to enclose the largest possible area. So that's going to be our target, that we're trying to maximize area. And it's just a rectangle, so area is x times y. All that needs to be done is to solve the first equation, the constraint, for either x or y. Substitute it into the other problem, and we are finished. So, 2x plus y is 1,200. Solving for y is easiest, so let's go ahead and do that. Make our substitution. Area is x times 1,200 minus 2x. And there we are. One variable for our target equation. We can enter that in. Y1 will be A for area. Y1 is area. And then x is just going to be x. So I'm not even going to mess with that. Here's the equation. X times 1,200 minus 2x. Setting up the window. Well, if I have three pieces that add up to 1,200, they'll be about 400 apiece. We're looking for a maximum area, so we'll expand that. Let's go to like 600 apiece. That gives us some margin for error. I'm going to change my scale this time, so I have tick marks every 100. Now, y is for area, so if the sides are about 400 apiece, that area is going to be like 400 times 400. That's probably not the greatest match, but not bad. Let's see what we get. The graph. Yeah, I should have worked a little harder at that, especially on a video, but it's not a difficult fix. I'll just go change it from 160,000 to about, oh, I don't know, 250,000. And again, you would just use the max button under calculated, the max choice, and that will give you the maximum area. And that's all there is to that problem.